In SAP exception automation, one critical design decision is choosing the correct expected quantity. SAP provides multiple quantity fields. One is the operation quantity recorded during confirmation. The other is the order header quantity defined during planning. These look similar, but they represent very different business meanings. Operation quantity reflects execution. It may change due to partial confirmations, rework, or scrap adjustments. It can differ across operations of the same order. Therefore, it is not a stable reference for expected production. The order header quantity represents business intent. It is the planned production quantity. It remains consistent across all operations. It provides a stable baseline for comparison. In automation design, planning data defines expectations. Execution data shows results. Therefore, expected yield must come from the order header. Actual yield comes from confirmations. The automation follows a simple structure. First, retrieve planned quantity from the order header. Then compare it with actual confirmed yield. Next, calculate variance. Apply business tolerance. Only meaningful deviations are flagged as exceptions. If we use operation quantity as expected value, results become unstable. Partial confirmations or corrections may hide real issues. Using header quantity ensures consistent and reliable exception detection. For additional robustness, we can validate operation quantity against header quantity. If both differ significantly, the system can flag a data inconsistency. This makes the automation adaptive to SAP data changes. Reliable automation depends on choosing the correct data source. SAP provides many signals, but automation must understand their meaning. Planning defines expectations. Execution shows results. When automation respects this structure, exception reporting becomes accurate, stable, and future-proof. Now let us carefully analyze the logic sheet that powers this exception automation. This sheet is where raw SAP confirmation data transforms into business intelligence. On the left side, we see the raw SAP confirmation data. Column A shows the order number. Column B shows operation quantity, technically known in SAP as main. Column C is the work center. Column D is the confirmed yield. Column E is scrap. Column F is rework. These are execution level signals coming directly from SAP confirmations. Next, we see the exception flag and exception type. These are the original SAP signals. For example, final confirmation with yield mismatch. Notice that SAP marks these as high severity. But SAP does not evaluate business tolerance. It only evaluates rule deviation. Now we move to the most important column in this sheet, planned quantity. This value is retrieved from the order header. It represents business intent. It does not change across confirmations. This is our expected baseline. In step 1, we calculate expected yield. For most standard cases, this equals the planned quantity. This represents what the order was supposed to produce. In step 2, we calculate variance. Variance equals expected yield minus actual yield. If the result is negative, it means production shortfall. If positive, it indicates overproduction. This is pure mathematics, no business logic yet. Now comes the most important part. Step 3 applies business tolerance. In this model, we apply a 1% tolerance threshold. This means small deviations are ignored. Only material deviations are flagged. For example, a variance of 1 unit on 100 units equals 1%. That may be operationally acceptable. But a variance of 10 units on 100 units equals 10%. That demands attention. The final column evaluates a true or false flag. If variance exceeds tolerance, the record is marked true. If within tolerance, it would be ignored. This converts raw SAP signals into meaningful business exceptions. Now a reference rows like shown. Let us take order 1000805 as an example. Planned quantity is 100. Confirmed yield is 90. Variance is -10. 10% deviation. That exceeds the 1% tolerance. Therefore, it is correctly flagged as true. Next. Now look at smaller orders. Order 6 million has planned 10 and actual 9. Variance is 1 unit. That is 10%. Even though the number looks small, percentage impact is large. This is why relative tolerance matters. Notice order 1000819. Planned quantity is 3,200. Yield is 0. Variance is -3,200. That is not noise. That is a real production issue. This demonstrates how automation separates critical signals from minor deviations. What we have built here is not just a filter. It is a structured decision model. SAP gives rule violations. This sheet evaluates business impact. That is the difference between data and intelligence. This is how automation evolves. We do not remove SAP exceptions. We interpret them. We apply business tolerance. We measure percentage impact. And we flag only what truly matters. That is enterprise-grade reporting. If we use operation quantity as expected value, results become unstable. Partial confirmations or corrections may hide real issues. Using header quantity ensures consistent and reliable exception detection. For additional robustness, we can validate operation quantity against header quantity. If both differ significantly, the system can flag it. If both differ significantly, the system can flag a data inconsistency. This makes the automation adaptive to SAP. SAP provides many signals. But automation must understand their meaning. Planning defines expectations. Execution shows results. When automation respects this structure, exception reporting becomes accurate, stable, and future-proof.